Hello and welcome to the physics lecture wherein now we shall be discussing about the types of substances. Basically, when we are undergoing into the concepts of magnetism, we should look into that there are three types of substances. First of all, the diamagnetic substances, secondly the paramagnetic substances, and third the ferromagnetic substances. Now we shall be taking a look at one by one that what are like the properties and what are the behaviors of each and every type of these substances. Say for example, presently the topic in hand is the diamagnetic substances, right? Now the diamagnetic substances are those substances which are actually repelled by a magnet or a bar magnet or a temporary magnet or a permanent magnet, right? Now say for example over here we did keep two bar magnets separated by a very close distance or by a very small distance. The north pole of this bar magnet is over here and the south pole of the another bar magnet is over here. And a container, say for example like a bowl, is being placed as such, like this way. So this is the container or the beaker. Now say for example, first of all, when we have kept this like diamagnetic substances without these poles of this bar magnet, it would have been in a straight line. But as the concept says that the diamagnetic substances are those which are repelled by a bar magnet, so they will tend to move from the stronger positions to the weaker positions. Now, from the characteristics of a bar magnet, we know that the stronger positions are at the poles and the weaker positions are over in these regions, as we have seen, like what will be their value of B at the dipole axis and perpendicular on the perpendicular bisector. So, now they will try to go near to the perpendicular bisector over here, near to the perpendicular bisector over here. They will try to go along the sideways and they will try to move away from the stronger position like this. So they will actually shape something like this. Right? Now, on the contrary, if we do keep the same arrangement, but now this is the north pole and this is, say, the south pole of another bar magnet. So this is the north pole, this is the south pole. The beaker or this container is being kept like this, but the main difference is that these two bar magnets are separated by a long distance, right? So now if they are separated by a long distance, in this particular scenario it will be observed that the stronger magnetic field region is now along the sideways and the weaker region will be along the poles, because this is separated from a very large distance, right? So they will be taking the shape like this. Right? So from these two diagrams now we could understand that when a diamagnetic substance or a diamagnetic liquid, better to say liquid because it is changing its shape, so when a diamagnetic substance is being kept in, say, a magnetic field, it tends to move from the stronger region to the weaker region of the magnetic field. So here comes the first property, that tend to move from stronger to weaker regions of the magnetic field B, right? And as it is being said that they are actually repelled by the bound magnet, so we can say the second property is that they are repelled by magnets, right? Now, say for example, if like a diamagnetic rod is suspended freely in an uniform magnetic field, at that point of time, that diamagnetic rod which is suspended freely, it will align itself in the direction perpendicular to the direction of the magnetic field. So, we can state as the third point, if suspended freely they actually align itself to the direction perpendicular to B. Align itself to perpendicular direction of the magnetic field B, right? Now, as we can see that if they are suspended freely, they align itself in the direction perpendicular to the direction of this magnetic field. Hence, we can say that the susceptibility of these diamagnetic substances are actually very small. So we can write that the susceptibility, which is denoted by this, the susceptibility is very small and of course negative. And it may be noted again that this, say for example, the susceptibility is invariant of the temperature, which means that if we are going to increase or decrease the temperature, it will not be having any effect on the diamagnetic substances. So we can say like this, and not variant or dependent on T or the temperature, right? Now, the permeability. The permeability of these diamagnetic substances, we can say that they are actually lesser than 1. So, we can state as permeability, as we know that this is denoted by mu. This permeability is basically lesser than 1, right? Now over here we could say that, right, if these diamagnetic substances are being placed in a magnetization field, right, it could, like, it is being repelled. But once this magnetization field is being removed from over there, this actually gets, like, the magnetism of this substance, it gets removed or it loses the magnetism. So we can say that if the magnetization field is removed, the substance loses its magnetization. We could write the magnetization here, the magnetization. So it is understood that for the scenario of diamagnetic substances, if the magnetization field is removed, then these substances, this kind of substances, or the diamagnetic substances, loses its magnetization, right? Now, for example, over here, if we say that, like, we could explain it with the help of a diagram, say, like, this is a magnetized, a diamagnetic substance, right? And it is placed in, like, a magnetic field. Now, if it is placed in a magnetic field, obviously over there, the magnetic lines of force will actually pass. Now, had it not been any kind of magnetic substances, the lines would have passed as if there was nothing, or it would have been perpendicular on the surface. But for a diamagnetic substance, if placed in a magnetic field, the magnetic field tends to pass through the surrounding rather than to pass through the inside of these diamagnetic substances. So the diagram shall look like but yes, obviously some magnetic lines of your force on the magnetic field lines will pass, but the majority, it will be the tendency to pass through the surroundings. These are the surroundings, right? And the direction, say for example like this. So we can say that if this diamagnetic substance, if placed in a magnetic field, the B, then the magnetic lines of force, magnetic lines of force tends to pass through the surroundings, as we can see over here in this, right? Now, say for example, if we are placing, say, this diamagnetic substance or a diamagnetic rod in a magnetic field, like in the same scenario, right? It will be observed that a weak magnetization will occur over here, but the direction will be completely reversed to that of that magnetic field, right? It could be understood that, for example, if you see the lines are going like this, obviously there would be an electromagnet over here or a strong magnet over here, and there will be the north pole of this and south pole of another magnet. Then only this magnetic line of force will travel in this direction, right? Now it is said that if we are going to place this diamagnetic substance in this B or magnetic field, obviously it is being seen that the magnetization occurs but is very weak. But the direction will be in opposite or reversing direction to that of this magnetic field. So over here we will see as if there is a north pole being generated in this direction and a south pole is being generated in this direction. This fundamental actually helps us in understanding the definition of our diamagnetic substances. If you remember, the diamagnetic substance are those substances which are repelled by a magnet. See now, the north pole of a permanent magnet is over here, and just facing to that there is the north pole of this diamagnetic substance. And same is the case for this south pole and the south pole of a permanent magnet. And as we know that like poles repel each other, so obviously there will be some kind of repulsion, right? So they will be repelling each other. So it could be stated as if placed in magnetic field, first of all, they develop a weak magnetization, right? Magnetization is observed, but it is very weak. They develop weak magnetization. Right? But in a direction opposite, but in a direction opposite to that of this magnetic line of force or the magnetic field. Right? Now, the examples of these diamagnetic substances. There are various diamagnetic substances like antimony, copper. Let's write the examples. Their examples are antimony, copper. Like after that copper, it could be zinc, and there are also other substances like gold, silver, mercury, etc. Say for the gold, silver, mercury. As we were telling initially that they were the diamagnetic liquids, so the mercury could be taken as an example for this, right? So we can take the example that it is Ag or mercury, because Ag, as we see that this is an example of a diamagnetic substance, right? Also, there are certain substances which we can treat as diamagnetic substances. The compounds, such as common salt. The common salt is obviously sodium chloride, so we can treat it as an example for diamagnetic substances, and yes, it has been seen that it actually has got the properties of a diamagnetic substance, so we can write it is as NaCl or the sodium chloride. And again, we could also find out the examples such as alcohol, right? So this is all about the diamagnetic substances, where we have seen that actually if it is like a liquid, a diamagnetic liquid if placed, it tends to move from the stronger regions to the weaker region. Obviously a magnetization happens within that, it develops a magnetization, but yes, it is weaker. And after that, we have seen that the permeability of it is lesser than 1, and yes, the susceptibility is very less, but it has got a negative value. And the examples such as copper, like antimony, zinc, gold, silver, mercury, alcohol, sodium chloride, etc. In the subsequent lectures, we shall be discussing about the paramagnetic substances and the ferromagnetic substances. Right? Thank you.